Hello everyone, myself Dr. Ashalata KS. Now we shall discuss about Leibnitz theorem and its proof. Leibnitz theorem, the statement of Leibnitz theorem. If u and v are two functions of x having derivatives of nth order and y equal to u into v, then the nth derivative of y is given by nc0 un into v plus nc1 un minus 1 into v1 plus nc2 un minus 2 into v2 plus etc. ncr un minus r into vr plus etc. ncn u into vn. So this is the nth derivative of the function of the product of the function u into v, where u1, u2, un and v1, v2, vn denote the successive derivatives of the function u and v respectively. Now we shall prove this result by using mathematical induction. Okay, so for that first step we shall verify the result is true for n equal to 1 or 1 and 2x. Let y equal to u into v. Now differentiate this by applying the product rule. It's u1 into v plus u into v1. Okay, or this can also be written as 1c0 u1v plus 1c1 u into v1, because 1c0 value is 1, again 1c1 value is also 1. Therefore this result is true for this result. Okay, again y2, differentiate the given function. Again you will get again product rule u2 into v plus u1 into differentiation of v is v1. Now go for the product rule for this term. It's u1 into v1 plus u into v2. u1 plus u1 into v1 plus u1 into v1. This becomes 2 times u1 into v1. So this can also be written as 2c0 into u2 into v plus 2c1 u1 into v1 plus 2c2 u into v2. So therefore the result is true for n equal to 1 and 2. Now second step, we should assume the result is or the theorem is true for n equal to m. Wherever n is there in the result, replace it by m and we'll assume this is true. So ym equal to mc0 umv plus mc1 um minus 1 v1 plus mc2 um minus 2 into v2 plus etc. mcr um minus r into vr. What is the previous term of this? Previous term of this term? It's mc r minus 1 u m minus of r minus 1 into v r minus 1 plus etc. mcm into u into vm. Okay, now we have assumed this result. In the next step, we shall show this result is true for n equal to m plus 1. Okay, for that differentiate this equation, that is equation 1 with respect to x. What is differentiation of ym with respect to x? Again it is ym plus 1, which is equal to mc0 as a constant. Now go for product rule to find the derivative of this. That is, what is the derivative, differentiation of this again with respect to x, that becomes plus 1 into v plus into differentiation of v is v1. Likewise, MC1, again product rule, um minus 1 plus 1, that becomes v1 plus minus 1 into v2 plus etc. Likewise, mcr minus 1, minus r plus 2, we have found out the previous term, no, its derivative. Okay, vr minus 1 plus minus r plus 1 into vr plus mcr, the derivative of differentiation of this again with respect to x, you will get minus r plus 1 into vr plus minus r into vr plus 1. Got it? Plus etc. The derivative differentiation of this is mcm u1 into vm plus u into vm plus 1. Okay, while differentiating, we have applied product rule for each of these terms. Okay, now we'll do grouping here. Okay, we'll take common terms. So the first term is mc0 um plus 1 into v. Okay, now observe the term here v1. Again in this v1, take it as common. If you take v1 common, you will left with mc0 plus mc1. Similarly, again observe these two terms, minus 1 v2, again here minus 1 v2. Take this as common. You will left with mc1 plus mc2 into u minus 1 v2. Likewise, take common from these two terms also. We are having common as minus r plus 1 into vr. Here also and here also. You will left with this. Okay. Plus, what is the last term? It's mcm u vm plus 1. Right. We know this results. That is mc0 combination equal to 1. Again, m plus 1 c0 value is also equal to 1. And mcm value is 1. m plus 1 cm plus 1 value is also 1. And we also know this result. What is that? mcr minus 1 plus mcr equal to m plus 1 cr. This is r. Okay, this is r. This result, we also know this result. Observe once again, mcr minus 1 plus mcr. This is nothing but m plus 1 cr. Right. Now replace, put r value as 1, 2, etc. What you are going to get? If r equal to 1, you will have mc0 plus mc1. Its value is m plus 1 cr is replaced by 1. m plus 1 c1. Now observe the term inside the bracket here. mc0 plus mc1. Now this can be replaced by m plus 1 c1. Likewise, this can be replaced by m plus 1 c2 and so on. So therefore, this equation can be written as mc0 can also be written as m plus 1 c0 because both the values is equal to 1. Right. So it is m plus 1 c0 um plus 1 into v. Now this can be replaced by m plus 1 c1 v1 plus this can be replaced by m plus 1 c2 minus 1 v2 plus etc. m plus 1 cr minus r plus 1 into vr plus etc. plus m plus here mcm value is 1. Again m plus 1 cm plus 1 value is also 1. Now replace this mcm by m plus 1 cm plus 1. Therefore m plus 1 c m plus 1 c m plus 1 into u into v m plus 1. Okay, so we have proved the result is true for n equal to m plus 1. Okay, where in the theorem wherever n is there, that is replaced by m plus 1. That means we have proved that is true for n equal to m plus 1. Thus, the theorem is true for all the values of n equal to m plus 1. Hence, by mathematical induction, we have proved the Leibniz theorem. Here is some important note. Go through it. That is, NC1 value is n by 1 factorial. NC2 can be replaced by n. That means its value is n into n minus 1 by 2 factorial. Then what is NC3? It's n into n minus 1 into n minus 2 by 3 factorial. Okay. If the nth derivative of y is yn, then nth derivative of y1 is yn plus 1. Similarly, what is nth derivative of y2 is, it's yn plus 2. We'll solve some problems by using Leibniz rule. Find the nth derivative of x cube e power ax. Okay. So, y equal to x cube e power ax, that is nothing but u into v. Okay. So, let u equal to e power ax and v equal to x cube. Now, u equal to e power ax, find its nth derivative, n minus 1th derivative, n minus 2th derivative. Likewise, again v equal to x cube, find its first derivative, second derivative, third derivative, fourth derivative. Likewise, now go for the Leibniz rule. What that says, nc0 un v plus nc1 u n minus 1. This derivative goes on decreasing and this derivative goes on increasing. U n minus 1 into v1 plus nc2 u n minus 2, then v2 plus nc3 u n minus 3 into v3. Why we have not written the next terms? Because v4 is 0. Okay, 0, the next term is nc4 u n minus 4 into v4. So 0 into anything is 0. Then what is v5? v4 itself is 0, means v5 is also 0, v6 is also 0, all the other terms will be 0. So, just substitute these values. We know nc0 is 1, nc1 is n by n 1 factorial. What is nc2? n into n minus 1 by 2 factorial. Substitute all these values and simplify. You will get the nth derivative of x cube into e power ax by using Leibniz theorem. The next problem. If y equal to sine of log of x plus 1 whole square, prove that x plus 1 whole square into y n plus 2. That means say nth derivative of y2 plus 2n plus 1 into x plus 1 into yn plus 1 plus n square plus 4 into yn equal to 0. Okay, we have to prove this result. First of all, consider the given function. Now differentiate this with respect to x. Okay, so look here, observe here the terms inside the bracket. Log of m to the power of n, isn't it? This is of log of m to the power of n form. What is log of m to the power of n? It's nothing but n log m. Right? Okay, now differentiate this. y1 is equal to sign differentiation, sign of this differentiation, cos of log of x plus 1 whole square or 2 log cos of 2 log of x plus 1 into differentiation of this log of x plus 1 is 2 is constant as it is. Log of x plus 1 differentiation is 1 over x plus 1. Right. Now cross multiply this x plus 1. You will get x plus 1 into y1, which is equal to, okay. Now write this cos in terms of sine. What is cos theta in terms of sine theta? Or we know the result, cos square theta plus sine square theta equal to 1, isn't it? Cos square theta or sine square theta plus cos square theta equal to 1. Okay, we want cos square theta means transfer sine square theta to LHS, we will get cos square theta equal to 1 minus sine square theta. If you want cos theta means root of 1 minus sine square theta, isn't it? Now apply that formula here. Cos can be written in terms of sine as, this 2 is constant as it is, root of square root of 1 minus sine square. Instead of theta you are having log of x plus 1 whole square. Okay. Now this sine of log of x plus 1 is what? What is the given function? It's sine of log of x plus 1 whole square. That is nothing but we have considered it as r, they have given it as y. Now replace this sine of log of x plus 1 whole square by y square. Since you are having sine square, so it is root of 1 minus y square. Now squaring on both sides, you will get x plus 1 whole square y1 square equal to 4 into 1 minus y square. Okay. Now observe what is that we have to prove. We have to prove x plus 1 whole square yn plus 2. That means we have to find out the nth derivative of y2. That is, we require y2. So again differentiate this with respect to x. Right. So go for the product rule. X plus 1 whole square. What is y1 square differentiation? It's 2y1 into y1 differentiation is y2. Plus, since it's a product rule, y1 square as it is, x plus 1 whole square differentiation 2 into x plus 1, which is equal to 4 as it is constant, 1 differentiation is 0. What is y square differentiation is minus 2 into y into differentiation of y is y1. Okay. Now divide the whole equation by 2 into y1. So this 2y1 get cancelled, here also 2y1 get cancelled, here also 2y1 get cancelled. What you left with? It's x plus 1 whole square y2, x plus 1 into y1. Now transfer this term to LHS. It's 4y equal to 0. Now apply Leibnitz theorem. Now go for the Leibnitz theorem. Find the nth derivative. What that nth derivative of x plus 1 whole square y2 for this term. Again nth derivative by applying Leibniz rule for this term, and nth derivative of 4 into y equal to 0. Okay. So I hope you remember the Leibniz rule. So it's nc0 x plus 1 whole square. Its nth derivative is yn plus 2 plus nc1. This term, this derivative goes on decreasing, that is yn plus 2 minus 1, that is nothing but yn plus 1 into the differentiation of this is 2 into x plus 1 plus nc2. This again decreases, it's yn, again differentiation of this is 2. Okay, so the next term will be 0. We'll leave up to here only. Now the next term, find the Leibniz rule for this term. Plus nc0 x plus 1 as it is, nth derivative of this is yn plus 1 plus nc1. This term, this derivative decreases, that is yn. And what is the differentiation of this x plus 1? Again it's 1 plus, no need of Leibniz rule for this. What is the nth derivative of y? It's yn equal to z. Right. Now what is NC0? It's 1. What is NC1? It's n. What is NC2? It's n into n minus 1 by 2 factorial. Again here also NC0 is 1, NC1 is n. Okay. So now further simplify this. You will get some common terms. Simplify this. Here you are having yn plus 1. Here also one more yn plus 1. Take it as common. You will be having x plus 1 whole square yn plus 2 plus 2n plus 1 into x yn plus 1 plus n square plus 1 into yn. Sorry, it's not 1, it's 4. Ultimate. It's 4 into yn equal to z. Here are some problems. Try to solve all these problems. And the derivative of x square sine cube x. Again, these are some standard problems. Try to solve these problems.